Hello everybody, this is Avantik here. Today we'll be discussing about nearest neighbors. The agenda for discussion will be fundamentals of nearest neighbors, some unsupervised learning that you can do with nearest neighbor algorithm. We can do classification using it, we can do regression using it, and after covering all these topics, we'll be getting into nearest centroid classifier, a very interesting case. Let's start with the fundamentals first. Nearest neighbors is non-generalizing learning model. Okay, what that means is, if you compare that with linear regression or tree, right? Based on the data, it is creating a data structure. It's creating a, in case of linear regression, it's detecting the coefficient, and based on this coefficient, it will do future prediction. So that is, generalized learning model, right? So it is creating a generalized coefficient which would work for the newer data. Okay, whereas nearest neighbor is non-generalizing learning model. That means it does not derive anything like coefficient which will be used for future prediction. It just stores all the training data in an efficient data structure. Okay, and the efficient data structures can be a ball tree, KD tree. You can refer to documentation for further understanding of it. Okay, and once you store the training data in a specialized data structure, all you have to do is, for a new data, you have to find uh, one approach is the nearest, okay, based on your configuration, that is your neighbors configuration, nearest configured neighbor. So by default it is 5. So you will consider nearest 5 neighbors, and based on the class of these 5, you will tell the new data belongs to this class. Okay, or if it is a regression problem, based on the neighbors, you will and the target value of theirs, you will find mean or median of it, and you will tell this is the target continuous value or the target regression value. Okay, so that's the whole concept. Based on the neighbors, be it by number of neighbors, or be it the other approach is by the radius. You configure the radius, you want to consider neighbors in this radius only. Okay, you, based on the number of neighbors or by the distance of neighbors, you can find out what will be the label of the new data. So that's the 2 point to understand. One is you can find neighbors by count of it. You can find neighbors by the radius of it. Okay. One more point to understand. It's a non-linear separator. That, okay. So if the decision boundary between the classes is very irregular, this learning method works pretty well, better than many others. Then let's get into how can you do unsupervised learning using this nearest neighbor technique. Okay, so as you can see here in the code algorithm, this is the data structure. So you have three options: ball tree, KD tree, and auto, right? You can choose one of these algorithms, okay, or by default it is auto, and you can configure the number of neighbors that you're interested in. Okay, so what does that mean? Based on the training data, it will be stored in this data structure. For a new data, or the for the new data, you have to figure out, based on this configuration, how many neighbors you want to consider. So in this case, you are considering only 2 neighbors. Okay, so this is unsupervised. So of course there is no class associated with the data. As you can see, we are generating data which looks like this, right? This is the data. This light blue points is the data, and this is the new data for which we have to find nearest neighbor. Okay, we have configured 2, and you are training the model with only the feature data. There is no target information associated, and what it does, it predicts for this point 5,5. This is 5,5, right? 5,5. For this point, it wants to find nearest 2 neighbors. That is what you have configured, and it returns you these are the indices of the nearest neighbors, 3 and 9. Okay, and if I have to plot this, these are the 2 points. Okay, let's get into unsupervised nearest neighbor. Okay, so this is the unsupervised learning. That means there is no target associated. Okay, so what all we have to do is for a given point, you have to find the nearest neighbor. Okay, and the distance is calculated by default using Euclidean distance method. Okay, that is, and just to put it, what is Euclidean distance? Suppose you have 2 points, which is this is your x1, y1, and the other point is x2, y2. So Euclidean distance is square root of x2 minus x1 square plus y2 minus y1 square, right? This is the distance between these 2 points. Okay, this is the Euclidean distance. So we have the data generated. This is how your data looks like. We are using make blob data module to generate this data. As you can see, this is the data. This is the point for which we want to find the nearest neighbor. Okay, this is the point. Okay, 5 cross 5. This is the point we want to figure out. First, what you do, given the data, you have to train the model, right? That means internet will be creating a data structure, KD tree, or ball tree. So you are doing a fit with the data. There is no target, there is no y. Okay, and we're not storing any y also here. This means that whatever return value is there, you're not taking it anywhere. Okay, so once you have created the data structure, that is all that will happen in fit function. Okay, you want to find nearest neighbor for this point 5 comma 5. There is this point 5 comma 5. You want to find nearest neighbors. Okay, and when you pass this data to the k neighbors function, once the model is trained, k neighbors, it returns you indices of the points which are closer to that. Okay, remember it's a array of array, so you basically have to get the inside array. That is why we did a 0 here. Okay, so it gives you 6 comma 9, and 6 comma 9, if you try to plot it, it is these 2 points, right? For this point, these are 2 nearest neighbors. So this is a very useful technique, right? Given a data of text, if you can vectorize it and then you can find nearest neighbors, you'll see that similar texts are closer to each other. Okay, and you can do this for images as well. Okay, you can vectorize the image and you can find nearest neighbors between it. It will show similar images coming closer to each other. That is your nearest neighbors for unsupervised algorithm. Okay, let's go for nearest neighbor for classification. Okay, as far as nearest neighbor for classification is concerned, okay, so what you're trying to do here, based on the neighbors, you can configure it by number of neighbors you want to consider. Okay, you want to configure by the radius to which you will consider your neighbors, right? There are two factors. Based on these values, you will get your neighbors, and your class would be the majority of your neighbors about, right? Because you believe similar data stays closer to each other. Okay, let's see how it's done. Okay, again we are using make block functions to actually generate some data. You can see there are two classes. The one is class deep blue, and there is one class with lighter blue, right? Aqua, the two classes, and the color is this way. So this is the distribution. Right? Okay, so in this situation, you cannot have a linear model which separates it. So this type of situation is pretty well handled by a nearest neighbor classifier. Okay, so again, just to mention, there are two types of classifier. One is based using the number of neighbors into consideration. One is using the radius into consideration. Let's now compare both of them. Okay, this is the data set and this is the plot, and all you have to figure out is what is the class for this point, red point. Okay, the value is 5 comma minus 5. If you use number of neighbors, so this is KNC represents my k neighbor classifier, that is number of neighbor to be considered. RNC classifications radius. Okay, so you're training both the model with same data, then you're doing the prediction over here. Okay, and here it is telling you that the data belongs to class 1. Okay, and we really want to see which are the neighbors it is considering. So all this nearest neighbor algorithm supports the function k neighbors. If you can give the data, it will give you what are the neighbors it is considering. So in this case, it is considering 7, 37, 32, 15, and 1. Right? It is considering all these neighbors. Okay, and in case of RNC, radius based nearest neighbors, okay, if you do radius neighbors, it will tell you what are the radius, like you have configured this with radius 5, right? This is how you have done. You have configured it with radius 5. You want to see at radius 5, what are the neighbors which gets considered. Okay, this is a list of the indices of the neighbors which get considered. Way too high, right? Okay, so we want to see it, really understand it. So this is with your number of neighbors you're considering is 5. 1, 2, 3, 4, 5. Okay, you can see majority, this light blue is class 1. So majority is light blue. So of course you give it light blue. It belongs to class light blue. Okay. Whereas if you're considering radius nearest neighbor, you can see for this point, it is considering this as radius 5. All these points are taken into consideration. Majority of it will win. So in this case also, 1, 2, 3, 4, 5, 6, 7. 7 belongs to class 1, which is the light blue, and 3 belongs to, so not 3, 1, 2, 3, 4, 5, 6. 6 belongs to the other class. Okay, of course, this guy wins. Okay, so both of them will give you the same parameters. Now this is like based on distance or based on the number of neighbors. There is one more parameter, like you naturally want a neighbor which is closer to you should have more impact, right? For that to happen, you need to configure this weight parameter in any of the nearest neighbor algorithm. If you configure weights is equal to distance, that means the neighbor which is closer to it will have a higher, will have a more impact in its state. Okay, so the weightage will be the inversely proportional to the distance between the new point and the neighbors. Okay, let's now understand what is the impact of number of neighbors in your decision boundary. Say your k is 1, that means number of neighbors you're considering is only 1. Your decision boundary is something like this because your number of neighbors that matters to is only 1. Okay, so of course not a smooth decision boundary. If you increase the number of neighbors, you get much more smoother decision boundary like that. Okay, so this is how you judge the value of k here. Okay, let's now get into nearest neighbors for regression. Of course, you can use nearest neighbors for unsupervised classification and of course for regression. The important point here to know is you have similar approach like k neighbor regressor and radius neighbor regressor. You will either use number of configured number of neighbors, or you use the radius from the new point to all the neighbors, right? Okay, and okay, so what will you do? You, based on your new point, you will find out which are the nearer neighbors, which are the neighbors to it, and the target value of the neighbor will be used in predicting the target value of the new point, right? To understand it, say you have, this is the new point and this is the data, right? So if you consider 3, 4, 4, 1, 2, 3, 4, these 5, say these are the points that is considered in nearest neighbors. So the target value of all these points, we can use mean or median of this target value to find the target value of this new point. That is what is nearest neighbors for intuition, right? Of course, you have, similar to your classification, you have the weight parameter over here. And one more thing to understand, this nearest neighbor regressor is capable of dealing with multiple outputs. Okay, it's just one output. You can imagine, like, if all the data points has multiple columns as target, your final column here can be mean of each column. So based on the feature, it will find which is the nearest data, and based on more than one column in the target, okay, it can predict more than one column in the target. So it is capable of predicting multi-output regression. Okay, so to explain this phase, we are using a phase data set. It's an inbuilt phase data set, all with the phases. Okay, we are taking down the data. Right, this is each data. What we are doing is we are dividing each data into two parts. Okay, half of the phase will use for training and the feature data, and half for target data. Right, you can see here. Okay, so you have 2048. Half of the, suppose this is the phase. Okay, we are dividing it into two parts. This is the feature data, and this is the target data. Right. So when you're training the model, you're training with this and this. Right. Once you train the model with this half of the phase and predict, this is the target, rest half of the phase. Given new phases, if you give first half of the phase, it is capable of generating next half of the phase. Okay, so here basically I'm dividing the entire data into two parts. First part is train X, train Y. Next part is train Y. Again, test X, test Y. You are using first 30. There are there are total 40 types of phases. First 30 you are using for training, and last 10 you are using for validation testing. Okay, so nearest neighbor regressor. We're fitting the model. See here, target is not one column but 2048, right? I mean, rest half of the phase. Okay, and once the prediction is done, training is done, you want to use it for prediction. You can see, this is the half of the phase you are using for training, and this is what it is prediction, right? Which is good. It's detecting that there should be lips and these features. It's doing that with very simple examples. See, it is from the half phase it's generating. See, it's coming pretty good. Half of the phase is generating rest half of the phase, right? You can say it's coming perfectly good, right? Let's now get to the next phase of it. Okay, the next one is nearest centroid classifier. It is also a classification algorithm, but it's a little different. And folks who might be aware of clustering technique like k-means, you'll find some similarity, but still there is a difference. Okay, so here you pass the data and you tell uh, and you give a class information to that. Okay, so what? Let me explain that with an example. Say you have this iris data. I think anybody by now knows what is iris data. You have 150 data sets, right? And each 150 data set and three classes. Okay, class 0, class 1, class 2. Sentosa, Virginica, Vertical, three classes. Okay, so when you give data with the class information, that's what you're doing in fit function. You are giving the data and the corresponding class. Okay, say all the data with 0 class, it creates one cluster. All the data with 1 class, it creates another cluster. All the data with 2 class, it creates, whatever data points, it assumes that to be that cluster. Then it calculates mean of these clusters. Okay, then for a new point, it just figures out whether this mean is closer or this mean is closer or this mean is closer. Based on which is the nearest mean, it belongs to that particular cluster. That means it belongs to that particular class. Okay, so that's what we did with nearest neighbor. So nearest class centroid. So this is how you import it. Neighbors nearest centroid. You're importing nearest centroid. Okay, and you are creating the model. You are training the model with the class information, with the data information. Once it is trained, you are doing the prediction over here. Okay, so this also works pretty good when you have classes of data pretty close to each other. Okay, it has similarities with k-means. There's the only difference in k-means. You don't pass class information that is predicted using the closeness of the data. Okay, here you're passing the class information. Okay, that's all from nearest neighbors. Thank you, everybody.